to present our final project for Peel Lajak Kuroy Eye tablet. So our team members consist of me, Lim Sin, Lu Aisin, Muhammad Nizar, and Fatin Amni. So for the project background, Lajak Akuroy is a manufacturer that produces health supplements, and the company produces at least 15 types of Lajak Kuroy tablets. And these tablets are produced in the Lajak Akuroy factory and popular among the consumers. So in the tablet manufacturing, the common problems encountered include the fluctuations in tablet weights and inconsistent tablet hardness. So these problems are due to the uneven powder flow into the dye due to poor powder flow properties, uneven feeder materials into the tablet press, and malfunctions of the pressing machines, and many more. So it is important for us to ensure the tablets uniform for every batch produced. So we are given the responsibility to monitor the quality of Peel Lajak Kuroy Eye. So these are we will show the data and the chart for our analysis. So this is the data given. We have weight, relative density, tensile strength, and at different shift. So we are given 200 data, sample data. So we extract this data into numerical form, tabular form, and graphical form. So first we can see that the sum of weight for different shift and the grand total, sum of relative density, and sum of tensile strength. And next we'll at different shift we'll also get the average of weight, average of relative density, and average of tensile strength. So next we'll get a descriptive statistic for the weight, relative density, and tensile strength. And for tabular form, we get the frequency for the weight, for the relative density, and also the tensile strength. This is the chart for the weight frequency, relative density frequency, and the tensile strength frequency.
Hello everyone, my name is Nur Fatin Amni, and I will proceed to the next part of our group project, which is Part B. Lajak Kuroy tablet is used to determine whether the weight of standard tablets produced by the manufacturers follow the normally distributed 350 mg with the standard deviation of 14 mg. So, the hypothesis statement is H0 equals to the weight of standard tablets follows the normal distribution with mean of 350 mg and standard deviation of 14 mg. But the H1 is the weight of standard tablet does not follow the normal distribution with the mean of 350 mg and standard deviation of 14 mg. Next, Table 2.1 shows the tabulation data for Peel Lajak Kuroy Eye tablet. In this table, we collect our data by creating a frequency table with a range of 5. Then, we calculate the probability P, the expected value EI, and OI minus EI, power of 2 over EI. And we find the X2 test equals to 5.4075 from the calculation in the table. The rejection rule of this part is shown in the figure 2.1. By using 5% of the significant level, therefore alpha equals to 0.05, and from the chi-square distribution, we find x2 alpha degree of freedom equals to x2 0.05 11 is 19.6751. Lastly, the conclusion for Part B is since x2 test equals to 5.4075 less than 19.6751, then we failed to reject H0. Therefore, we can conclude that there is significant evidence that Peel Lajak Kuroy Eye tablets produced in December 2021 do follow the normal distribution with the mean of 350 mg and the standard deviation of 14 mg.
Hello, my name is Lu Ai-Sing. So let's move on to the part C. Present the required analysis and comment on whether there is any significant difference between tablet weights from the different sheets. So the method used is the one-way ANOVA test, which is carried out by using the Microsoft Excel. This is because the ANOVA test is used to analyze the difference between the means of more than two groups, which in our case there are three groups in total, which are morning, evening, and night shift. So for the hypothesis statement, H0 is no significant difference between the tablet weights from the different shifts. H1 significant difference between the tablet weights from the different shifts. Or we can write in the simple form as shown in the slide. So to carry out the test, the raw data is regrouped by separating the tablet weights according to the different shifts as shown in the slide. So we can know that the number of groups K is equal to 3 and the total number of sample size capital N is equal to 200. So the Microsoft Excel is used to calculate the parameter needed, such as the number of sample size for each shift, total number of sample size, sum of square, degree of freedom, mean square, and so on. So the result are as shown at the figure. So the significant level we use is 5%, which is alpha is equal to 0.05. So the p-value we obtain is 0.7431. So F calculate is 0.2974. So for the p-value we get from the Excel, which is 0.7431, which is greater than the alpha 0.05. So the F calculate is located at the regions of accepted H0, which is here. So in conclusion, since the p-value is greater than alpha, then we accept H0. Therefore, this test can be concluded at 0.05 level significant. There is no significant difference between the tablet weight from the different shifts.
On the current data in December 2021, what is the prediction of the tensile strength for such tablet based on the given relative density? From this figure, we can obtain the information of the estimates of A and B, which are represented by the rows for intercept and relative density. Therefore, our A is 0.27793 and B is 0.07445. Thus, the simple linear regression can be obtained and expressed by substituting the estimate of unknown regression coefficient as shown below, which is y is equal to 0.7745x plus 0.27793. In order to predict the tensile strength at given relative density, we can substitute the given relative density into the equation below. Therefore, we can obtain the tensile strength. So the prediction of the tensile strength with the relative density of 68%, 74.3%, and 80.1% is shown below. And it shows that there is a strong linearity relationship between these two variables. The hypothesis statement for H0 is B equal to 0, while H1 is B is not equal to 0. In this case, the p-values for our B estimator is 2.41 times 10 to the power of negative 54. This value is much lower than the chosen significance level, which is 0.05. Thus, B is significantly not 0 at 5% significance level, in which where we need to reject H0 and accept H1. To summarize our presentation up, by performing goodness of fit test in part B, there is significant evidence that pil Lajak Kurui eye tablet produced in December 2021 do follow the normal distribution with the mean of 350 mg and 14 mg standard deviation. For part C, by performing ANOVA test, no significant difference exists between pil Lajak Kurui eye tablet from the different shift. Lastly, for part D, for the prediction of the tensile strength for the relative density of 68%, 74.3 and 80.1% are 5.54453, 6.0 6.327 and 6.4168 megapascal respectively.